Project Jump Cannon. Is it just another Ethereum Stellar Bridge, or is it something much more? Well, I think to find out exactly what it is, we need to jump into the article by Tumawela, and I'll see you on the other side. Project Jump Cannon choosing Webassembly. What is Webassembly? Well, I guess Webassembly is Webassembly. From what I understand, it's a more efficient way. It's actually coding for talking to your machine, your computer. It actually, you can code the binary to, flip the switches up and down for the ones and zeros. So it actually operates more quickly. Like, for example, JavaScript will not tell the computer what to do. There is another programming language in between that, Webassembly, and you've got bridges between. That's my understanding. It might be completely wrong, but look into it. But let's read the article by Tumawela, sorry. This is obviously a while ago now, April the 1st, 2022. So, Project Jump Cannon is moving forward. In previous episodes, we outlined the reasoning for working on native Stellar smart contracts now. The Stellar ecosystem is in an advantageous position to implement smart contracts, learning from research that has already been done, marching forward equipped with a diverse toolbox, and implementing Stellar smart contracts in a way that is true to the things that makes Stellar what it is: safe, scalable, and promotes equitable access. One of the first major decisions to make in building a smart contracts platform in 2022 is choosing a smart contracts platform. This post is going to walk you through the decision-making process, the options we consider, and the pros and cons of each. But if you're just here for the grand finale, TLDR, Project Jump Cannon is being built on Webassembly Webassembly runtime. For those of you sticking around to learn how and why we chose Webassembly, let's carry on. Over the past couple of months, SDF team has focused on surveying the current smart contracts landscape. We want to use the most appropriate technology and learn from the broad cryptocurrency ecosystem. Our team has created a stack selection document with our selection criteria and a thorough comparison of existing technologies. If you're interested in all the nitty-gritty details, check out the docs. We'll probably check out the docs at some point. We do need to understand a little bit more here at Zioncoins about this Webassembly, what it can entail, how much more efficient is it going to be to run your smart contracts that way. But this blog post is lightweight version of the docs, so let's run through this quickly. I'm not going to read the whole article. There are some parts that are a bit long-winded, but let's crack on. First, what do you mean when we say smart contract stack? Well, a lot, but here's a condensed version with 4 components. The virtual machine, VM. This executes bytecode instructions in a sandbox environment. It doesn't really know anything about the blockchain. The blockchain runtime services, these connect with the virtual machine, with the blockchain, ledger, storage, gas metering, etc. The language toolchain. This allows developers to write contracts in a human readable language like Rust, Solidity, and so on. The Rust, Solidity, when I think Rust, I think Ada. When I think, or Solana, when I think Solidity, I think Ethereum, another Ethereum-based smart contracts, EOS. Contract development SDKs. These ease the development process by providing libraries, documentation, and test sandbox, and more. In the perfect world, we'd pick a technology off the shelf. that covers the entire smart contracts stack. That might not be realistic, given the differences between blockchain protocols and implementations. With that said, at minimum, we'd like to choose an existing virtual machine and programming language. These are well-researched fields, and even though our team includes language creators, we don't need to reinvent the wheel. The stack selection criteria. We considered the following criteria to evaluate the technology options. First and foremost, we asked ourselves, is it capable enough? If the technology can't facilitate the type of smart contracts we're looking for, it's a non-starter. We then looked at various aspects of the design. Does the storage model promote long-term accountability for state and manageable ledger sizes? Do transactions lend themselves well to concurrency or partitioning? How are developer ergonomics? That's a big that's a bit subjective, but we want to make sure the development experience isn't too weird. So yeah, I mean, like as a developer, you want to be able to flow from one language into the other without too much of an issue. So that's quite important. You know, if you're more Python based, there is some learning to do. Even JavaScript. We analyze the existing implementations for performance, maturity, and how tied up they are to a specific blockchain and execution environment. Lastly, we looked at the maturity of the ecosystem, how many existing contract developers and developer resources exist. These are the lenses we examined the options through. There's a lot of smart contract tech out there. Here are some of the noteworthy options we looked into and our general take on each. So, obviously, Ethereum virtual machine provide a smart contracts option. You can use a virtual machine. You don't even need to buy and sell using a virtual machine. It's free, it's open source to use. Like if you've ever heard of Flare, the Flare network. Flare network uses the Ethereum virtual machine, and actually, they've got a bridge from XRP to Flare. With the use of that, and Flare actually have the bridge from Flare to Stellar as well. So they've bridged with a number of different cryptos. But anyway, the Ethereum virtual machine, or EMV, is the elephant in the room. It was developed alongside Ethereum and is driving the majority of the activity in the DeFi space. It is most commonly used in the deprogramming language, but others, such as Viper, exist. exist. The EMV also used in a variety of other networks such as Avalanche, CeeLo, Phantom, and others. It's by far the most popular smart contract stack. It's mature and it has an abundance of developer resources, tools, and best practices available. However, its storage and execution models are expensive and challenging to parallelize. This makes the validator software less accessible and gets in the way of scalability. In addition, having been built specifically for Ethereum makes EMV adoption in existing networks extremely challenging. Moving on to Move. Move is a smart contract stack designed by and for DM blockchain. Now, if you remember DM, or if you don't know, DM used to be called Libra, which was Facebook's cryptocurrency. So they've got their own blockchain and their smart contracts software stack. The stack includes a virtual machine programming language toolchain, a dedicated approver, and other dev tools. Move is carefully designed from the ground up as a comprehensive blockchain stack. It gets a lot of things right, including one-of-a-kind verification language and prover that were built alongside the language. On the flip side, it's fairly immature, still in work in progress, no significant ecosystem, and the current executor is very slow. In addition, Move storage model presents a programming model that developers struggle to grasp. Now, WebAssembly. This is what WebAssembly is. WebAssembly is a bytecode specification created for running sandbox applications in the browser. It's used by various chains in different configurations: Polkadot, Terra, Near, Elrond, Dfinity, etc. Now this is where we find out what it is. WebAssembly, WASM. WASM is a bytecode specification created for running sandbox applications in a browser. It's used by various chains in different configurations: Polkadot, Terra, Near, Elrond, Dfinity, etc. It's most commonly used with the Rust programming language, but there are others. WASM lends itself well to smart contracts as it was designed to operate in an environment that, much like blockchain, is extremely adversarial. The web. As a VM, WASM presents the widest set of possible source languages, toolchains, interpreters, and JITs, and presents the best performance and lowest degree of coupling to a specific chain's semantics. However, it leaves open the problem of designing the rest of the stack. Blockchain agnostics and specific runtime services, as well as a source language APIs, SDKs, and or special bindings, domain-specific languages like JavaScript. There are several chains to study and learn from, but none fits Stellar well enough to adopt unchanged. So, there you go, that's unchanged. Interestingly, the Ethereum community has been advocating for using WASM in Ethereum as early as 2015. The Ethereum Foundation also developed eWASM, a restricted subset of WASM to be used in Ethereum 2.0. With the change in definition of Ethereum 2.0 throughout the years, it's unclear whether eWASM will ever be implemented in Ethereum. However, this suggests possible re-encounter between eWASM stack and Ethereum ecosystem down the road. So really, I mean, we can read on what eBPF is. You should really give it a read. Obviously, this is Solana's use of it. Let's just run through it quickly. eBPF for smart contracts is a fairly unique choice, and Solana makes many bold claims about it. However, the real benefits are unclear. eBPF as a virtual machine is subsequently similar to WASM as a target for multi-languages through native tool chains, but the support is worse and the maintenance burden is higher. One major difference is that eBPF interpreters typically optimize for low latency startup, but increasingly this is the case with new fast WASM interpreters. Solana's concurrency and storage models are more promising as design input to our own efforts, but present safety and performance hazards significant enough not to adopt, so unchanged. WASM is it. So yeah, read through this and look, with let's just go through it real quick. WASM is it. There are many more smart contract options. Some of them are blockchain dependent, some rely on UTXO model, and some are just fragile. We're keeping an eye out for these, but this blog post is getting a bit too long. You could say that again. I might actually cut that bit out. So back to the bottom line, we're focusing on WASM for Project Jump Cannon. We believe it provides a robust execution environment for smart contracts as a thriving ecosystem and can be used to build a system that is safe, scalable, and promotes equitable access. With that said, many questions remain: which WASM implementation to use, which source languages to support, what is the contract storage model, what is a contract parallelism model, what is the interoperability story with the existing Stellar protocol, and more. So the interoperability story, is it going to be a bridge for other cryptos like Ethereum, like Polkadot, like Elrond, like Avalanche, like Solana? Is it going to be the bridge? Well, we'll just have to watch this space. Thanks for watching the video. Once again, I'm Nathan, aka Nathan of Zion. Don't forget to like, subscribe, smash the Zion coin up there, and check out the next video. See you in the next one. Take care now.